Hey everybody, this is Larry. This is me doing the daily prom on October 23rd, and we have the new weekly prom as well. So let's get to it. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prom. It's a hard problem. Maximum score of a good Subarray, 1793. I'm in Hong Kong right now, still been a very draining week, so we'll see how that goes. But I am getting enough sleep, so that's always good. So yeah, that's a start. Let's take a look. The score of a subarray I and j is equal to min of that subarray times j minus I plus 1. A good subarray is a subarray where I is less than k. What's k? Is less than equal to j? What? Oh, they give you k. Okay. Return the maximum possible score of a good subarray. Okay. Um, Maybe is this like mono Q time or something like this? Because well, I mean, this is a little bit of a cheating hint in a way, in that that's what um in that that's what that's what we did yesterday. Sorry, man, mind blank on trying to figure out the word to say. But that's what we did yesterday, so maybe today's similar. So that's why I kind of jumped to it, not for any particular reasons. But we are getting a min of a subway, and so immediately I am going to try to think whether there is a sliding window, right? Which is the same idea, but I don't know if that's true. Let's look at the constraints real quick. Constraint is n is equal to 10 to the fifth. So it's going to be big enough that we can't do anything more naive, just in case that we can, right? Um, what is k? I is oh, actually, I misread this good subway part. Huh. So that means that so in this case, a good subway isn't or the this constraint part of the subway, which is just meaning that it has to contain that index, right? Pretty much. Yeah. Okay. So what does that mean? That means that, for example, if k is equal to 3, we start at 7, right? Mm, I think I don't know if I would call it sliding window, but I think the way to think about it, maybe some sort of gradient sorting. What I mean by that is that we'll try to go to the left one at a time or right one at a time, and maybe in a greedy kind of way. Like here we have 3 and a 4, so we're going to choose the 4 first, right? Because that changes the minimum, the least, and this one changes in a very monotonically kind of way. And then next, we 5 and 3 will choose the 5 because that's 3, right? So we get another score from the index, right? And then, well, now that that's done, we're forced to take a 3. And of course, given the 3, we can take the 4 as well for 3. And then now we calculate this. And then lastly, we add the 1. I think the greedy idea kind of makes sense, right? But of course, as I always say about greedy, it makes sense until you get a wrong answer. You're like, well, maybe it didn't make that much sense. It just made a little bit sense. Um, I think I'm okay with playing around with that because I think the idea is that, and a lot of this is experience. And when I say experience, it doesn't always mean just like, oh, I memorized this problem. It's about like the feeling of things a little bit. Of course, some of these, or a lot of these feelings are backed by experience and practice, but sometimes it's hard to articulate, of course. Um, but what I mean by that is that this min function, right? We basically, in a way, we're brute forcing in a weird way, maybe if you want to phrase it that way, in that we're basically um, we're treating the step function as um, like okay, what is the maximum min, right? And then basically you kind of think of it the other way. It's going 7, okay, and then the next one is going to be 4, and then the next one's going to be 3, and then 1, and then try to calculate what is the score for those for every time min changes, and we try to change min in a very smallest way possible, right? Like the least change possible every step of the way. So that's basically, I think, the idea that once you, I think that's a good enough idea. Yeah, I think that's a good idea to kind of get started on. Sorry. Let's do it. And then here, I think I'm trying to maintain a loop invariant, right? And the loop invariant is that every step of the way, every time we make a change, what I want to say, every time we make a change, the min changes to minimally, and we have all the in a greedy way expand as much as we can. Okay. So while loop is while left is I like to write it this way, or right is less than n. So that means that if they go out of bounds, or if they both out of bounds, then we're good, right? So okay. Is this the right way to write it? It's a little bit awkward. But also this is like inclusive and not inclusive, so that's kind of very awkward. Okay, something like this, right? Okay, yeah. Then current min, or whatever best is the best score, whatever current min is equal to, say, infinity to start, or actually I guess just num sub k, and so best is actually also num sub k, because yeah, okay, that makes sense. And then now we here first we try to find the next min, and the next min, assuming that we already expand as far as we can, it's just going to be if let's see. Actually, I liked it this way, I think. Right. So left is station 2 and right is less. Yeah, okay, yeah. So then now we can go try to find the next min by going left or right. So if num sub left is greater than num sub right, then we go left, right? So then now here, current min. Oh no, if it's equal to num sub left, right? Else num sub current min is equal to num sub right, and then now we're trying to expand left and right as much as possible. So that is going to be while num sub left, and of course, while this is true, and this I'm thinking about how I'm writing this. It's so awkward, but I think the way that I'm writing it, or not awkward, we just have to make sure that this is inclusive or exclusive, and with an inconsistent, that's going to be a mess. So we just have to, yeah. The way that I'm writing this is, I mean, this is inclusive in this part, so we have to make sure that this is, yeah. So this should be inclusive. So while num sub left is less than or equal to, or greater than or equal to current min, then we or left. So the way that I want to write it is exclusive, so that's why it's a little bit awkward. So let's look at do I want to? Okay, how do I write this so that it's inclusive, right? So we only yeet the next item if right? But then now this is gonna be, this will never terminate. right? So yeah, if this is inclusive, how do we terminate it if it's inclusive? If so, basically this is inclusive if this is true. If both of these are true, then we're done, and then none of these, so minus tolen, so something like this, right? Yeah, so they're both at the end, then that's fine. And then now we have to go right as well, so while right plus 1 is less than n, yeah, it's very easy to kind of mess up by 1, so that's why I'm trying to be careful. And then now the inclusive, so the best part about inclusive is that we're able to do this calculation easier, right? So it's right minus left plus 1 times the min. So let's give it a spin. Maybe it's infinite loop. Oh yeah, I have to always move at least a little bit, so this is a little bit wrong. So then now, if yeah, this part isn't inclusive, so that's why. What am I doing? It's a little bit inconsistent. Because basically we're trying to see the next min, so this is technically this, which is fine, but then now we have to deal with weird left-right statements, right? I guess if no, but left could be 0 though, right? So that's why it's a little bit awkward. So try, all right, go left if it's bigger than a relevant, right? So I guess it's if left is, if right is equal to n minus 1 or this, because if right is already done, then we have to go left, otherwise we go right, but both of these cannot be true, so that should be finer. Yeah, maybe. Yeah, there you go. Am I gonna submit? I think I'm just gonna submit just because I'm lazy, but to kind of think of weird cases, but let's try at least like an obvious thing. Okay, it doesn't seem to terminate. And the way that I do it, even though there are 2 while loops, this should be linear because left only goes left n times and right only goes right n times. So it may look a little scary. Shouldn't time out. Unless I made a mistake. I mean, it times out if I have like a infinite loop thing, but not because, and it seems like maybe we do have it. Whoops. Let's see. I mean, yeah, the way that I wrote this is a little bit sketchy because maybe we go right when we shouldn't. So yeah, let's see. What is this task? Is 5, so 0, 1, 2, 3, 4, 5, right? So then now we try to go left, and we go and we're already done with left. So there's probably something weird here, right? So left is equal to 0. Oh yeah, so then now here, it's a little bit awkward because it's going left still because it's looking at the last element or something weird. Because left is equal to 0, right? Yeah, okay. This is very awkward, but I don't know if I recommend this. Yeah, I mean, it's very hard to get precisely right with these inclusive bounds, exclusive bounds. And apparently it's very hard to get it right. Okay, so if left is equal to 0, we always go right. Is that true? Yeah, but this is making me sad. Did I do? I think I did it, but I made a lot of mistakes last time too. Okay, I mean, I think the idea is right, but maybe not. Maybe I'm really wrong with that one. Maybe I'm lying. What is this? 314. But the inclusive exclusive bounds is kind of tricky for me anyway. Okay, so if left is equal to 0, that means that we want to always go right. Is that true? Yeah, I mean, I think that's fine, but because they're all right, right. Let's try the other case where we go all right first, right? So we make this 792, say. That should go all right. Okay, so this, oh, it doesn't even run because, what? Oh, no, this ran, but I guess maybe I had an extra space. Okay, so that looks good. So what is this wrong for? That's a little bit annoying. So that means a calculation error if this is bigger than the expected answer, right? Because if it's smaller, then you can say maybe I'm doing a suboptimal algorithm. But here, that means at the very least, as an implementation error, because we're basically giving an impossible answer. Oh, there, that's brighter. I can see it. If it's the same, we keep on expanding. Yeah, I mean, this is right. It's a little bit awkward, but should be right. This part seems sketchy as well, to be honest. So let's separate them out. I don't know. Maybe I'm just. I don't know how to syntax. I don't think that should do anything. But I just don't get. I just want to at least separate out the logic. Okay, fine. Let's print out current min. Let's print this out. I mean, I don't know. And left, right, and then this calculated score. And then, yeah, let's see. So we have, even from the get-go, did I misunderstand the problem? I don't think so. Even from the get-go, we kind of, got this wrong. Let's see, so we went left 5 times. This is inclusive, so the formula should be right. We already went higher though. What is 314? This is so silly, but okay, fine. Let's print out the array. Let's print out, what's it, nums? We also turn on do not disturb. Focus. Keep pinging me. Okay, so there's this. So 3011. We go left, 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 left. This is all less than. That's 6 numbers. Did I misunderstand the formula? I'm using a manual calculator. 6 times 60776. Yeah, I mean. Huh? I mean, it may not. This looks okay. We have 706, so then that means that we have 6 numbers. Where's the? I'm trying to find the 3011 in the input. I guess they just didn't print it, or maybe it's behind the real wall. Oops. Yeah, I don't get it. Am I misunderstanding? Oh, I am well, I didn't misunderstand it, but the min is. Okay, I am dumb. I actually was lazy on this part. I thought that when we expand, we always gets smaller, but that's not true from the first time because I'm silly, and the silly part is just that I need to expand before this, so I had to do this part. Oops, I had to do this part, and I'm a little bit whatever. So. Yeah, so I have to do like something, or I can just do, I could just do this. I'm too lazy, so it doesn't really change anything. Oh man, that is such a silly mistake. And now I fix this. Why is that? K is equal to 2, 0, 1, 2. So expand 5, 5, 5, 5, 5. Oh, it's because now this is our bounds in a weird way. Because the 4, we expand the 4 to and then now left is equal to 0. The invariant no longer holds. Okay, fine. I mean, I think it should be the same as here, right? I don't think that changes anything. Okay, so 0. I set my print statement here by accident, but that's good. So 4, this should not go to 7 because it starts at 2, right? Oh no, am I looking at the wrong? No. Oh, I got it. I forgot to. That's why I kind of put it in there, but then I forgot it in both cases, which is that I forgot to update the best for now. Okay, fine. Yeah, that very silly mistakes in general. Let's give it a submit. And there you go. Well, what a day to do a 1300-day streak. Linear time, linear space. Hopefully the algorithm makes sense. This was I guess the last time I did it was about the same, but a little bit. I mean, that was a little bit sloppy, but this is a little bit sloppy. So, what am I to say? But yeah, but the idea is simple. The implementation very tricky with the bounds and kind of constraints. But yeah, that's all I have for today. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.